Okay, for topic two, we're going to look at reciprocal and quotient identities. And when you're dealing with anything in math, if they introduce something called an identity, it's just an equation or a statement that is always true. Okay, so when we think identities, it is something that is always true. And at some point, we'll prove some of these identities. We can use these identities when we're solving and simplifying. For now, we just need to kind of introduce a few of them. So first, we have the reciprocal identities, and these should not be totally shocking. In the previous topic, we were looking at just defining the six basic trigonometric functions, and we found that there was a relationship. So if we look at sine, there was a relationship between sine and cosecant. There was a relationship between cosine and secant. There was a relationship between tangent and cotangent, and that relationship was a reciprocal relationship. We could see that the ratio of sides for sine was the reciprocal of the ratio of sides for cosecant, and so forth with cosine and secant and cotangent and tangent. Okay, so that's what the first three identities are going to be. We have here that cosecant theta is equal to 1 over sine theta. Secant of theta is equal to 1 over cosine theta, and cotan of theta is equal to 1 over tangent of theta. And I don't have time to show you that all of these are true, but I can prove at least one of them is true so you can understand how this really works, okay? So let's go to another just blank page. Okay, in the previous example, we had a right triangle, okay? So in example one, in part one, or the first video, topic one, we had a right triangle like this. And we knew that the adjacent side to theta had a length of 12. The opposite side to theta had had a length of 5, I'm sorry. And then we were able to use the Pythagorean theorem to find that the hypotenuse had to be 13. And from there, we found the six basic trig functions. We found, okay, well, sine has to be 5 over 13 because the relationship between sine and theta and the ratio of sides is opposite over hypotenuse. For cosine, the relationship is adjacent over hypotenuse. So that would be 12 over 13. Tangent, the relationship is opposite over adjacent. So 5 over 12. Now, we know that cosecant, the relationship is hypotenuse over opposite, so 13 over 5. These are reciprocals. We found that secant, the relationship there is adjacent over hypotenuse, or rather hypotenuse over adjacent, so 13 over 12. And cotan, the relationship we're looking for is adjacent over hypotenuse, so 12 over 5. Reciprocals, 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 okay? So let's prove this is true. We were just told that cosecant theta is equal to 1 over sine theta. Well, let's see if this is really true. We know that sine of theta is 5 over 13, so we would have 1 over 5 over 13. Well, that's really just 1 divided by 5 over 13. And if you remember anything, remember that when you're dividing fractions, first fraction stays the same or first number stays the same, and then you multiply by the reciprocal of the second. So this really becomes 1 times 13 fifths or 13 fifths, which is exactly what we got for cosecant. So that's kind of how that works. If you say that cosecant theta is 1 over sine, you literally take 1, divide it by whatever sine is, and you'll get your cosecant. So that's how that works. I'm not going to show you for cosine and tangent. Just know that that's what they're referring to. That's how that works. Okay? So let's go back to our worksheet. So those are our three reciprocal identities. We now need to talk about quotient identities, and those involve tangent and cotangent. So we are told right here that tan theta is equal to the ratio of sine to cosine. So it's equal to sine divided by cosine. And then because we already know that tangent and cotangent are reciprocals of each other, we can then say that, well, cotangent would have to then be cosine divided by sine. So again, let's prove it using that other blank sheet of paper. So I'll just prove one of them. I don't really have time to do both. Okay, so we have this same triangle, okay? If you've labeled theta, we have the adjacent side is 12, the opposite side is 5, and the hypotenuse is 13. So we're saying, well, tangent of theta is equal to sine of theta divided by cosine of theta. Well, let's see what that means. We have here that sine of theta is 5/13, and we have that cosine of theta is 12/13. We have that right here. Well, when you divide two fractions, that's really what this is. This is just division of two fractions. We have 5/13 divided by 12/13. And again, if you know anything about fractions, when you're dividing fractions, you multiply the first by the reciprocal of the second. So this becomes 5/13 times 13/12. Well, 13s cancel, leaving us with 5/12, which is exactly what we got for tangent. Okay, so we're seeing more and more relationships between the angle theta and these ratios of sides. Okay, so let's go back to the worksheet. Okay, so you've got your reciprocal identities, you've got your quotient identities. Let's play around with this. Okay, so example two, I'm going to shrink this just a little bit so it fits better. So example two says use the provided information to find the remaining trigonometric functions of theta. So what we're going to do here is we're going to use the identities. We're going to use the quotient identities and the reciprocal identities, and then I'll show you, like, if we draw a triangle, how everything is legitimate. Okay, so tan theta we know is equal to sine theta divided by cosine theta. You do need to remember that, okay? And we are told over here that sine and cosine are given. So we're told that sine is root 10 over 10 and cosine is 3 root 10 over 10, okay? So let's do a little work here. So we have root 10 over 10 divided by 3 root 10 over 10. Well, that's really just root 10 over 10 times, or divided by 3 root 10 over 10. And remember, you multiply the first fraction by the reciprocal of the second. So we get root 10 over 10 times 10 over 3 root 10. Well, let's see, does stuff cancel? In this case, absolutely. Root 10 cancels, and we're left with just 1/3. Okay, now let's look at cosecant. We know that cosecant is the reciprocal of sine, and that is one of those things that you do have to just memorize, okay? So cosecant is really 1 over sine theta. Well, sine of theta is root 10 over 10. So that's really just 1 divided by root 10 over 10. So we know we multiply the first by the reciprocal of the second. So we get 1 times 10 over root 10. So that gives me 10 over root 10, but here's the thing. You have to kind of go back to Math 171. You have to rationalize your denominators. You're going to rationalize a lot of denominators in this class, so it needs to become something that you're very familiar with. So if you're not familiar with it now, you need to work on it because it's going to come up. So in order to rationalize the denominator, you're trying to force the denominator to be a rational value. Square root of 10 is not rational, okay? So what we do is we multiply numerator and denominator by root 10 over 10. And this right here is really just equal to 1. And we already know from the most basic facts of math that if you multiply anything by 1, you're not changing the value. So we're not going to be changing the value of 10 over root 10. We're just taking that radical out of the denominator, okay? So the numerator becomes 10 root 10. The denominator is root 10 times root 10, which is just 10. So the 10s cancel, and I'm left with just root 10 here. Okay. Now, whoops, I need to go back to black ink. We're told that secant is the reciprocal of cosine. So that would just be 1 over cosine theta. So we know from over here that cosine theta is 3 root 10 over 10. So this is really just 1 divided by 3 root 10 over 10, which is really just 1 times the reciprocal of that, which is 10 over 3 root 10. Now, it's going to be really helpful if you don't have to show every single one of these steps every single time you do that. I'm showing it to you now just to kind of remind you of how some things work. As you work through this, try to gain a little bit of confidence. Practice this and gain a little confidence where you don't have to show every single step every single time, okay? Now, what we have here is 10 over 3 root 10. We need to rationalize, so that means I need to multiply top and bottom by root 10. So let's see, I get 10 root 10 over 3 times 10. Square root of 10 times square root of 10 is just 10. So the 10s cancel, and I'm left with root 10 over 3. And that is a root 10. It looks kind of stupid. Let me fix that, actually. I don't want it to be too confusing. So we get root 10. Good grief, I did it again. It's late. So we've got root 10 over 3. That's maybe a tiny bit better. Okay. And then finally, we know that cotangent is, you can do this two ways. It's cosine divided by sine, or it's the reciprocal of tangent. So either one of those is fine. In this case, reciprocal of tangent is going to be so much easier. So we know that this is 1 over tan theta, which is 1 over 1/3. So it's 1 divided by 1/3, which is really 1 times 3 over 1, or 3. Okay, so using those reciprocal and quotient identities, we were able to find the other 4 basic trig functions knowing what sine and cosine were. Now, there is an alternate way to do this that I think is actually a bit easier. You could draw a right triangle. Pretend that's a beautiful right triangle. I am many things, and artist is not one of them. Okay, we're going to denote where theta is. Now, we know that sine is the opposite side of theta over the hypotenuse. So that tells me the opposite side compared to theta is square root of 10, and the hypotenuse is 10. So this is opposite. This is hypotenuse. That tells me that cosine, remember, is adjacent over hypotenuse. So 3 root 10 is the adjacent side. And 10, we already know, is the hypotenuse. And using this, we can use that idea of SOHCAHTOA to find the different trig functions. We already know sine and cosine. So we know tan theta is opposite over adjacent. So that would be opposite, which is root 10, over adjacent, which is 3 root 10. And that would simplify to 1/3. Okay, we know that cosecant theta is the reciprocal to sine. We know sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite, which would be 10 over root 10. We would have to rationalize, so we would just get root 10 here when you simplify. And you can slow this down and do some of the arithmetic. I'm trying to show you this one a little bit quicker. Now, secant, we know, is the reciprocal of cosine, okay? So it ends up being the hypotenuse over the adjacent side, which is 10 over 3 root 10. We have to rationalize, and we end up getting, let's see, 10 root 10 over 3. So 10 root 10 over 3 times 10, which is root 10 over 3. And then finally, cotan, we know, is the reciprocal to tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite, which is 3 root 10 over root 10. Root 10s cancel, and we get 3. So you have 2 ways you can approach this. I think what we just showed with the triangle is a heck of a lot easier than using these reciprocals, but know how to use the reciprocal and the quotient identities, because there are going to be situations where maybe we can't draw the triangle and we need to know those reciprocal and quotient identities. Okay? Now I think that's it for this video. Yeah, so that'll be it for this one.